Okay, so the week 5 notes are split up into 2 different parts. So this is part 1 of week 5, and this is talking about the discriminant. And as I go through, I'll actually explain what that means, and we'll kind of discover what it looks like together. You will need to sketch graphs. So you can see that there's like a graph there. You don't need to make it perfect. We're just going to sketch. I'll show you how to do it, which means you probably need a calculator. Remember, go back and look. It's a little bit farther down. I'll actually put it with this announcement too. But there was an announcement that I had put up earlier that showed you the graphing calculator that you can use on the computer. So if you have your own, just use that. Otherwise, there is a graphing calculator in another announcement that you could be using. So the first thing we're going to do is we're going to go through and sketch all the graphs. If you can see this well enough, you can just follow along with me. In order to do it, it needs to equal 0 first. So if there's any of them that don't equal 0, we need to start there in order to graph. So x squared plus x minus 2, and then we'll graph it. And again, you're just going to sketch the graph. If you want to put little tick marks on and make it a little more accurate, that's okay. But really, a sketch is all you need, but it needs to look similar to this graph that's right there. Okay, so we're going to come down, and it's here, and then comes back around. That's good enough for the sketch. And then we'll do number 2. Okay, so all we're doing right now, nothing, oh, sorry, I did forget one part. Number of x-intercepts. So the x-intercepts, how many times does the graph cross the x-axis? That's all it's asking. So this one has 2. Okay, so that's all you have to do. So again, I would pause the video real quick, do that all by yourself, then just come back real fast and check them all. But in case you get stuck or you don't have a calculator or you can't get it to work, just follow along with me. So 3x squared minus 22x plus 7. And then we graph. Okay, now this one goes really far down the graph. That's okay. Like when you sketch it, I would just draw it all the way in, but it starts way up high. It's gonna come way down here and then go back up. Totally fine. Again, the number of x-intercepts? 2. All right, I'm just going to go ahead and do 3 and 5 next. That way I don't keep moving the calculator back and forth. But you can do the other order if you want. So minus 8x plus 8. As long as it all equals 0, we're good to go. And we graph it. Now again, when I ask you to sketch, I'm not asking it to be super perfect. Like you don't have to put all the points, but be careful on this one. If you notice on this graph, we're going to start up here, and then it just goes right there and then back up. So the number of x-intercepts on this graph is actually just 1. So you do need to make sure you're a little more accurate. Don't make it go all the way through the x-axis because that's what makes it have 2 x-intercepts, and this one doesn't. And then 5, negative 3x squared. Sorry, negative 3x squared plus 6x minus 3. Okay, so it's going to, this one, because it's a negative a value, come up and come back down. And the number of x-intercepts, still 1 on this one. And then we'll jump back over. That way, again, I didn't have to keep moving the calculator back and forth. So on the next one, we're going to have, if it's set equal to 0, we're good to go. 2x squared minus 9x plus 13. But this one starts up here, comes here. Number of x-intercepts? None. You can say 0. That works too. And then the last one. Now on the last one, again, notice it equals negative 4. So in the case of that, we're actually going to add 4 to both sides. Okay, so we'll have x squared minus 8x plus 4 equals 0. And then we'll graph that. So x squared minus 8x plus 4. And again, this one's a little bit larger, but again, good enough for the graph. And it has 2 x-intercepts. So all we started out doing at first was going through and just drawing the graph and writing down how many times it crosses the x-axis. There is a pattern, though, about what's happening, and that will go along with the next part. So now we're going to go back, and we're going to find b squared minus 4ac. Now, if you remember from when we did these problems before, standard form, which is what all these are in, we have ax squared plus bx plus c. And so when it's talking about b squared minus 4ac, it's talking about the a, the b, and the c. So the one thing I will ask you to do as we go back to the top is we're going to label the A, B, and C for every single problem that we're doing. And then I'll write it at the top part too, but we're just going to fill in to b squared minus 4ac. Now, one spot we have to be really careful with, and I'll demonstrate with the calculator as well. Make sure the b squared always goes in parentheses, because this is where we'll make some careless errors if you're not really careful with the calculator. And it's a good thing to practice, so I would make sure that you're looking at that. All right, so if we come back, again, you should always start by labeling the A, B, and C. So in the case of the first problem, A is 1, and B is 1, and C is negative 2. I know you can't see it anymore, so I'm going to write it at the top of the paper. So again, I suggest that you always put the B in parentheses. So B squared minus 4AC is the formula that we're using right now. It's at the bottom of the paper too, but that way you can still see it. So we're going to do 1 squared minus 4 times 1 times negative 2. And I can tell you when we're in class, this one isn't one that you would mess up on. But as we go through them, I'm going to demonstrate one other time. I'm not going to do it for all of them. But I'll show you what would happen. And again, it's a little bit tougher because I know I can't see your calculator, so I can't really show you what you're doing wrong. But if you get stuck and you can't get my answers, just take a picture and send it, put it in the discussion post so I can look at it. So exactly what I wrote down is exactly what I'm typing in the calculator. And I push enter, and I get 9. So again, that's what we're finding. That's your b squared minus 4ac. We're just going to leave that alone for right now. That's what I'm looking for. And we're going to go through that and do it on all the problems. So I'll show you one more with the calculator. And then again, I'm sorry, for the rest of them, we'll just keep going. So A is 3, B is negative 22, and C is 7. And so then we just fill in. So again, put the 22 in the negative 22 in parentheses, and then minus 4 times A times C. So again, you're typing in just like how I wrote it down. Okay. Minus 4, and you can use parentheses here too. Oops, not a 9, parentheses. And then push enter. And when we do that, we get 400. Now let me show you what will happen. Like if you're like, well, I didn't get that, this is what you probably did. You didn't use parentheses around the negative 22. It's really, really important that you use parentheses around that negative 22. The b squared, the b has to be in parentheses because that's your other option, and that's not right. Remember, we talked about a little bit before, what it's doing is, what I needed to do is negative 22 times negative 22. I want it to be the same thing twice. That's why it's in parentheses squared. If you don't use it, so the second way I typed it in, that's doing 22 squared and then taking the opposite. So that's a very different number. You just have to be careful. So again, those are the setups. Those are my two examples. Everything else, for the most part, is all done the same. So then we have A is 2, B is negative 8, C is 8. And again, this is where we get to a point where I would pause the video, see what you can do without me, and then come back and check answers. So that one's 0. Again, this will lead us into our part 2 notes. So it's really important that you are labeling your A, B, and C. I know sometimes like, well, I can just look at it and put it in real quick. But again, this will lead us into what we're going to do on the next set of notes. And I know sometimes careless errors come in if we're not careful. This one is negative 23. Okay, there is a pattern that's starting to show up, which we'll look at in 1 second. So A is negative 3. Sorry, I was working ahead. A is negative 3. B is 6. C is negative 3. So 6 squared. Whether it's positive or negative, I always put the B in parentheses so that you're always consistent and we don't make any careless errors. And so then we get 0. And again, on the last one, use when we had it set equal to 0. Don't use the original. Come to what we already had done when you do A, B, and C. So A is 1, B is negative 8, and c is 4, because that'll also make some mistakes if you're not careful. And so then negative 8 squared minus 4 times 1 times 4. And on this one, we get 48. So if you take a look at these, you'll start to see there's a pattern between the number of x-intercepts and then what we got for the b squared minus 4ac. And again, the b squared minus 4ac is a very special name that we have for it. So if we start, I want you to look, if we do that b squared, if we do that b squared minus 4ac equals 0, something's happening. So the 2 that equals 0, okay, how many roots did they have? How many x-intercepts did they have? Oh, just 1. You'll see this written, like you can call them x-intercepts. I'm going to write it a different way as well. They'll also just write 1 real root. That's also what they're called. Remember, x-intercepts, roots, zeros, solutions, all the same things. We just got to make sure we're interchangeable with some of those names. Then what we can also notice is that if we have b squared minus 4ac, we only have 2 other options. So either it was 0, or then we have 1, 2, and 6 all have one type of number, and then 4 is a different one. So 1, 2, and 6, all of those are greater than 0. That means it's positive. When it works out, you get a positive answer. Okay, so if you want to write that with it, you can. That's all that means. Greater than 0 just means it's positive. When it's positive, that's going to give you 2 solutions. Okay, so that then gives you 2 real roots. Okay, and then the last option is for when you work it out, we do b squared minus 4ac, and it's less than 0. Well, if it's less than 0, that means it's going to be negative. And if it's negative, we didn't have any. So you can say no real roots. And that's good enough. I'm going to show you another reference paper that actually does one more thing that's a little more specific, but I'm good enough with these answers. There is one more thing I can show you that'll just put one more extra element in for those of you who want to push yourselves just a little bit more. b squared minus 4ac is called the discriminant. So the whole point of finding the discriminant is to tell us how many roots we have. They're solutions. That's what it's going to tell us. So the discriminant tells us how many, I'm going to write it lots of different ways. Roots, solutions, x-intercepts, zeros, the problem has. Remember, all of those words are interchangeable. That's why I listed them all. Again, you usually see it talking about roots, but they can also talk about solutions. And again, it leads to everything else as well. So this is just the first part. The discriminant is b squared minus 4ac. And what the discriminant does is it tells us how many solutions, roots, zeros we have to the problem. So when you work it out, if it's going to be a positive number, you have 2 solutions that cross the x-axis twice. If you get 0, it only touched the x-axis. It didn't cross through it. And if you get a negative number, then it's none. You don't have any. Okay? There's also a reference paper that you can look at. And again, this reference paper takes it one step farther. This is what we just looked at. Okay, how many answers that you have. They use the word imaginary. Again, that means no real roots. That's what imaginary. You'll learn about imaginary numbers in Algebra 2, but not yet. And then these two, if it's greater than 0, perfect squares. This is the special case. The perfect squares give you rational roots. Okay, perfect squares like 1, 4, 9, 16, 25, like those are your perfect squares. Still positive numbers, but it's a special type of answer that you'll get. Both of these, you can just say 2 real roots. The extra part, again, because we're not together and I can't keep going it over with you, I'm not really concerned about. So these two both give you two solutions. It's just this has a special term with it. And again, that's where this part comes in. And all of this is on Canvas, so you can have this reference paper. You can look at it or print it off. This is the discriminant. The quadratic formula is what we're going to go into with part 2 of your notes. And look, there's a discriminant right there, b squared minus 4ac. This is really important, and we'll talk about that in the next set of notes as we lead into using the quadratic formula, which helps us actually find the solutions. And again, here they use the word solution, so I can show you. It doesn't really matter. They'll interchange those words. But b squared minus 4ac, if it's positive, the 2 real. B squared minus 4ac, if it's negative, none. And b squared minus 4ac, if you get 0, it just has the 1. So that's the first layer. And then we'll go on and then also work on using the quadratic formula to actually find the solutions.